friends! Isn't the weather lovely? Wait a minute! Is it me? Or is the ground moving? Whoa! Be careful! It's a landslide! Let me tell you about this natural disaster!
Landslides are natural hazards that generally occur due to shear in bodies of soil, rock, or other geologic matter. Certain geographies are required for an area to be vulnerable to a landslide, as gravity is the driving force for slope movement. Smaller landslides can occur in lower sloped areas, but usually the steeper sloped areas create the most perilous disasters. The increase of the slope creates greater shear stresses within a body, as well as applying larger gravitational pull before and after the motion of materials begins. The structure of a landslide can be mapped by examining the locations of the toe, scarp, and surface of separation. The zone of accumulation, the area where accumulated materials resides, is of particular importance. This area is typically where the most property damage and loss of life occurs. The distances from crown to tip and flank to flank, and the depth to surface of rupture will quantify the amount of accumulation. Simply put, when the shear stress in a soil body exceeds the shear strength of the body, movement will occur. Landslides are often thought of as macroscopic processes. The real story is a microscopic one. A key factor in the occurrence of soil landslides is frictional strength. As the frictional strength of a soil body is overcome, particles begin to roll over each other. And as is well known from classical physics, static friction is always greater than kinetic friction. The frictional strength of a soil body is also affected by water saturation. The lubricating water between grains creates pore pressure, which forces the soil particles to spread out, lowering the friction between soil particles and the cohesiveness of the soil. As the cohesion is lowered, so is the shear strength. As the water pressure applies force in all directions equally, it creates a buoyancy effect as well. The principal stresses are offset by normal forces of the particle. But if one side of the soil body is unconfined, at a steep slope for example, the normal stresses will exceed frictional forces, which results in soil liquefaction. Surfaces of rupture have a specific circular geometry. The Swedish slip circle method is used to determine the total stresses within a soil body at multiple arcs within the soil. These calculations can be used to find maxima within the soil and make failure predictions. This method can only be used for saturated clays in short-term analyses and assume an angle of friction of 0. The ordinary method of slices is also used to estimate shear forces within a soil body. This process discretizes the soil body to provide more nuanced calculations of normal forces which are directly proportional to shear forces. For solidified bodies, such as rock or cemented material, cracks or fissures are enlarged by normal stresses, creating rockfalls and rock slides. These breaks in the body could be pre-existing, formed by geological stresses from tectonic movements, formed through erosive processes, or even by daily cycles of thermal expansion and contraction. Erosive processes may also undercut a structure, shifting the burden from tensile to shear, with the shear strength of a solid mineral body typically being the weaker of the two due to its crystalline structure. Over time, continued erosion can enlarge the cracking, providing less surface area for stress distribution. Once this happens, hold on to your hard hats. Large landslides, especially mud flows, occur frequently in hilly areas after periods of extended, intense rainfall. Deforestation of hillsides, wildfires, and the additional runoff due to impervious surfaces affect soil morphology and consolidation, while presenting greater effective stresses as soils accumulate more weight from water and deeper saturation levels. Landslides may also occur as a secondary disaster from other geologic events such as volcanic activity and earthquakes. Vibrations from volcanic activity and earthquakes can induce stresses in the earth body which can overcome shear and tensile strengths. Flooding and heavy rains associated with hurricanes can reduce the cohesive strength of the soil bodies and lower their frictional resistance. Measuring the severity of a landslide is done through standard static means such as total volume of material displaced, distance traveled, and affected area. Temporal and dynamic measures are also employed, such as the duration and the maximum speed of flow. Realistically, these measures mean little to humankind unless there is a loss of life or some type of economic disruption. In modern times, the scale of an earthquake is defined by its scope: how many people died, and what will it cost to rebuild.